Greetings, this is Mr. Garwood with our series on Briggs, Cochrane, and Gillette's second edition calculus textbook. Today I'm going to combine chapter sections 2.4 and 2.5 so I can really discuss and try and set the clear expectations of the difference between a limit at infinity and infinite limits. We're going to start with figure 2.26, which is found on page 64 of your text. And I want to start by talking about what does it mean to be an infinite limit. As you'll recall from our earlier discussions on limits, when we discuss a limit around a point, we're going to talk about what is the function doing as it comes from the left, and what is the function doing as it comes from the right. So let us start our discussion by talking about what is going on around when x is 1. So when x is 1, we look over here and function tends to be blowing up, which is actually an official math term. So the limit as x goes to 1 from the left, well, it's increasing very quickly, and we actually will say that the limit there is infinity. Well, if we also look at from the right, just as the left-hand side is blowing up, so too is the right. So I have the limit x goes to 1 from the right is also infinity. Now, infinity is not a number. It's a concept of just something extraordinarily large. But our definition of limits from before was that if this and this were the same, then the limit existed, and we just said that the limit was that value without any specifics on it. It didn't have to be from the left or the right. So we can actually say that the limit as x goes to 1 of this function is infinity. That's okay. Now, just because they're blowing up, just because there's a vertical asymptote here, does not mean that the limit always exists. So let's consider now what happens when x is 3. So we're again going to talk about from the left and from the right, and I'm going to do all of this work over here on the right-hand side. So I'm going to talk about what happens around x is 3. Well, just like before, we can talk about what's it doing on the left-hand side. That's blowing up in the negative direction, so I can say that the limit as x goes to 3 from the left of this function. I see now that everything on here is g. I apologize, so I'm just going to come in and change all of their lettering. Well, it's negative infinity. And as we come from the right, it is increasing without bound. So the limit as x goes to 3 from the right of this function is infinity. Now, negative infinity and positive infinity are not the same. Not all infinities are created equally. So here, just as before, because these two things are not precisely the same, we can say that the limit as x goes to 3 does not exist. Now, so with infinite limits, when we talk about vertical asymptotes, we can have where the limit exists at a vertical asymptote. The key is they either both have to be going in the positive direction or they both have to be going in the negative direction. If they do opposite of one another, that function does not exist. Now, the other thing that I want to look at in this video is the idea of a limit at infinity. So here we were looking at a specific function value is what we're looking at the limit around. Now what we're going to talk about is what is the function doing as x tends to positive or negative infinity. So we're no longer going to be just looking at x equals a number. We're going to say as x tends to infinity and x tends to negative infinity. Okay. This time we can only go to positive infinity from the left. We cannot approach it from the right. So we're considering what happens as x gets very large in the positive direction. Well, we can see here, the textbook writer showed us that this is a horizontal asymptote. So as x tends to infinity, f of x is tending to increase, but it is not increasing without bound. What we see here is this horizontal asymptote, the function is going to come along and get impossibly close, so we can say that the limit as x goes to infinity is L, whatever this value is. Now, we're never going to put any kind of negative or positive subscript like we did before with talking about from the left and the right. We can only approach infinity from the left. And so we're going to choose to just, either it's converging to a value or it doesn't exist. So we can't talk about it's got to be the same as from the left as from the right. We can only talk about it coming from the left. And it either exists, it either converges to something, it has a horizontal asymptote, or it does not. So doing the same thing, we can talk about the limit as x goes to infinity to negative infinity. And just as before, we see here, this is decreasing and converging towards this horizontal asymptote at m. Well, just as before, we can say, well, the limit. Notice again here, I cannot talk about going to negative infinity from any direction other than the positive, from the right. So I don't have to put the little plus sign there. It's just understood. And we say the limit as x goes to negative infinity of f of x goes to m. So with infinite limits, it has to be a horizontal asymptote, just as we could see here that with our limits at infinite limits, they had to be a vertical asymptote. When I talk about limits at infinity, we are only talking about horizontal asymptotes, or they do not exist. Now, our last example I want to look at, this is figure 2.22. I apologize. Figure 230 is found in section 2.5 of the text, and it is found on page 71. And I want to wrap up with figure 2.22, which is found on page 2. Apparently I'm having some difficulty finding it. It is before page 62. Anywho, we're going to look at what's going on when x is a. We're going to look at what's going on as x tends to infinity. And we're going to look at what happens as x tends to negative infinity. Okay? So with a, with any particular value, I'm going to talk about what's it doing as it goes to the left. I'm going to talk about what's going to the right. And we'll go from there. Now we notice so we can say that this thing is bouncing all around. I apologize. The limit as x goes to a from the left of our function. Well, we can follow this trend line up. It tends to infinity. It's going up without bound. Similarly, from the right, this function is increasing without bound in a positive direction. And so, hey, look, from the left it's going up to infinity, from the right it's going up to infinity. That means the limit as x goes to a does exist, and that limit is infinity. So we have an infinite limit. Now we are similarly going to talk about, well, what's going on as x goes to positive infinity. So we're going to look at what's going on here. I follow this function value, and it looks like it's converging to this horizontal asymptote m. So I'm going to say that the limit as x goes to positive infinity, remember here I cannot talk about anything about a left limit or a right limit. It is purely it exists or does not, and here x, or the limit f of x is tending to m as x goes to positive infinity. Similarly, we can talk about what's going on as x goes to negative infinity. We look at this value, it looks like the function is converging to L. So I can say that the limit as x goes to negative infinity of f of x is L. The terminology here is really why I wanted to focus on this video. Please note that an infinite limit is the limits from the left and the right of any value are tending in the same direction, either in the positive direction or the negative direction. A limit at infinity is what is the function doing? Is it converging to some kind of horizontal asymptote as it goes to positive infinity and or as it goes to negative infinity? I hope you find this video useful. Good luck in your continued studies.